I think for this one specifically, during the parsing phase, I can probably just go through all these tokens and then combine them as a byte stream and then just have one operand, like treat this as one operand, essentially. So an operand itself can have like some structure as well, right? that's the thing. So it can either be a let me refresh my memory. Hang on, I have a list of all of them. There, GameBoy instructions, right? So they can either be symbols, which could also be an alias. They have immediate values. Which could also be labels or aliases. Then we have indirect stuff here. Let's look at the old parser for a second, because there was something in the code that I remember that like really annoyed me. But I have to refresh my memory on this one. This is fun code. So let's say LD. That's probably the most complicated one. I remember I had the stupid flags. Right. Okay, I kind of already had similar code like this. So I had this read operand thing right here. And then I would work on the operand type. Depending on what it was. Yeah, there's a whole bunch of shit going on. I don't quite know how to make it better at this moment. Oh. Are we back? Did my stream crash? Oh no. Okay, seems to be back. I guess I had my stream crash. Shoot. Yeah, it just stopped in the middle of it. Oh, well. I don't know how long it's been gone for. I hope not too long. I have not looked in the chat for a while, so... Oh dear. Anyways, if you're back, welcome back. That sucks. I'm not sure if it was on my end or Twitch, but it was probably on my end. Maybe my Wi-Fi bogged out or some shit. Oh well. Okay, so I don't really know how to do this better just yet. And also there's, with the operands itself, there will be things like, arithmetic operators now. So I have to think about those, right? On how to do so. So we have plus, minus, times, and divided. So I have to think about those. Because I want the ability to subtract addresses from labels. So I can just say, instead of counting all those lines in the bytes, right, I just want to say tiles end minus tiles. That will give me like the bytes between those two labels, between those two address points. And then if I already have minus or plus, might as well just do these two. But let's just do labels for now. So labels will actually already be interesting enough because we need to think about, well, the position of those labels, right? So where in the output file are we at that given moment? And then it also needs to be added to the the dictionary and the symbols table, right? So the symbols table I do not have yet, but I do have the hash map right here, which will be essentially the symbols table. So we already need to think about that kind of stuff. So if today I just gonna be able to do symbol definitions, that will already be quite a big step, I think, for this parser. And a good first start. So I'm going to be focusing on that. Okay. Well, so let's just do type def struct label, right? Label definition. Struct so what do we need for the label? We need, well, the identifier, right? We need to know what's the name of this label. Then we need the address of the label, meaning the position in the output file that it's pointing to, right? What do I actually need to do with the label? So I counter a label. So let's say I have this assembly file, right? I have label 1. I need to check the symbol table to see if it exists already. And if it does, that's an error. If yes, print error. If no, add to symbols table. And then read the next, if it is a label. So really, I just put the labels into the symbol table. I do not even need to have them in the syntax tree because there's nothing I need to do about those, right? I can already do that in the parsing stage. I just check if this label already exists or not, and if not, just add it. Hey, Kakerlaken Joe. Yeah, it's going alright. I had my stream crash a while ago, like 15 minutes ago or so. But otherwise, doing okay. Okay, let's add a symbols thing. GB assembler symbols. Right. Symbols.h, and then we do the same with include symbols.h, and this is symbols.c, right? And then here in main, we do include base symbols.c. Yeah, no, the PC luckily is fine. And by saying that, I probably just jinxed it and it will crash. Nah, it should be fine. Famous last words. Anyways, okay, so the reason why I want to start with the symbols table right now is because we probably do not need to have the labels in this syntax thing after all. And then I just realized I don't just need the identifier and the position in the bytes. I also kind of probably want to store the source location it came from, right? Because I want to be able to say, yeah, this thing came from this file on this line in this column, right? So then once we parse further, and let's say down here we have label 1 again, we want to be able to say, no, you already defined this in this file, in this line, in this column, you dummy, right? Something like that. Yeah. So symbols table is essentially just the hash map, right? So the only thing that we need to specify is like, okay, what kind of value do we actually want to store? Well, and that is quite easy. It is symbol information, right? So really what we want is a struct symbol, right? Hey, IO means life. So we have a symbol. And we have a type def for this one here. Passive-aggressive code, yes. Don't worry, I will not insult the users in the end. Maybe. Maybe I can put that in as a command line flag. Insult me. For the hardcores out there. Okay, so what does a symbol have, really? So we do not need to store the key because, like, that is already the symbol name, right? We can just look for the key. That is fine. The key is the symbol name, essentially, right? So, and this is also what we will storing in the dictionary. So what does it need? It needs... Well, we kind of want to figure out what kind of symbol it is, right? Because I also want to store keywords in here. Okay, so what symbols do we actually have? We have... Let's go through all the types of symbols. We have label definition, right? We have a keyword, which is any one of these. So an alias, header section, whatever, LD, CP, JP, right? Registers like so, A and stuff, all this kind of things. Those are all keywords. Data, right? So an alias is a keyword, but you give an alias a name, right? And you want to figure out whether this name is an alias or not, right? So if you type this name anywhere, it will just replace it with this value, right? So similar to a macro or whatever. Not quite the same, but like essentially. So you will have an alias, right? What does the label need? It needs the position in the output ROM it points to, right? It needs the source file where it came from. Line, column, and byte position in that file. An alias probably needs these things as well, right, for good error handling. But it also needs substitute, right? So what is it actually an alias for? Let's just call it data or whatever. Now, a keyword itself just needs a value. Right? Because it's a system keyword, we do not need to specify where it's from or what it's doing or any that sort of nonsense. Now we maybe could distinguish about like types of keywords, like is this either an instruction, a register, a flag, an operation? No, operation doesn't make sense. Flag or what's the word for it? What did I call this in the old one? Hang on. I have keyword, label, and alias. I had unresolved in there. Interesting. Really? I stored unresolved stuff in... That doesn't seem right. Oh, I think I had unresolveds in there, so I can actually, as soon as I find a definition but have an unresolved stored within the symbol table, I could then, you know, resolve it, essentially. And then anytime I find it later on, it will automatically be resolved. But maybe I should just resolve them at the end, all of them. I'll think about it. Let's just call it assembler instruction for the lack of a better name. I just can't remember the word, but those are things that are basically just only for the assembler code, not actually for the machine code, so it's not a machine instruction, it's just a thing like this data keyword right here, right? Or something like that. Or header, if you want to set the header title, right? Glad I named it Mario. Let's just call it hello. And I don't know if I want unresolved in there or not. Anyways, okay, so this means I need types of symbols, right? So probably what I want is a type def enum symbol type. Let's just be clear. So symbol type label. keyword. Feels like keyword should be the first one, no? Alias. Well, I can just leave those out, to be honest. Right. Okay, then we have the symbol type, and then probably the symbol data, right? Which will be one of these things. And I could make this a union. This is what I did in the old one, I think. But that's slightly overkill, I think, especially for keywords, because then they're holding on to a lot more data than they actually need to, right? I mean, I could just have it to be pointers or a number, right? So actually, why not? Union, right? So it's either gonna be right. Honestly, I'm just gonna copy this one because I already have all these keywords here. I'll just change it to the syntax. Right, so those are all the keywords, and we have call, red, alias, and data are self-defined ones. Okay, hang on, I have to take this one. Okay, apologies. Okay, so we got the keywords. Those are just the assembler instruction keywords. I'm not going to add the specific ones like label and alias in there for now. You know what? Let's remove that. Let's just add what we actually have. So, and now a union like this could basically look something like that. So you either have a keyword, right, which is just a keyword type for now. Actually, keyword type is probably a better name, right? Keyword type. Let's do this for all of them. keyword type, right? So symbol type keyword. So a symbol can either be a keyword type, right? Or it's gonna be a label, whatever the label is gonna be. So let's have type def struct label, right? Didn't I already write this? I mean, let's take this definition right here. Just copy paste that shiz over here. A label definition, yeah, that seems right. So the identifier we no longer need, really. That is nonsense, right? But we do need this. Okay, so we have the position, we have the file name, and then the line, the column, and the position. Oh, okay, let's call it offset. You know what? How about we call this the address, because that's actually what it is, right? The output address of this label definition. And then I can just name this position. Maybe I should make this into its own struct as well. Because like this, I kind of need a lot throughout, right? I've been using that quite a lot. Like we have it in token. Except for the file name. See, okay, this is where the difference comes in again. But I mean, at least position, line, and column I could wrap together. Nah, it's fine. It's fine. It's fine. I'll just leave it like this. Let's not get carried away here. Okay. So this is a label definition. And a label definition can go in here. And let's make this a pointer to a label. Why not? Right. So now our symbol can either be a keyword, which is just going to be an integer, right, or an address, which is 64 bits. So in either case, it's just going to be 64 bits. Yeah, and let's not worry about alias for now. Okay. Then we need to be able to create a new symbol, right? So they should be somewhere in memory. So symbol T, right? We just need the pointer for this symbol. No, new symbol. We have a memory arena. Do I want to specify the type already? And then maybe do this. Right. So symbol T, get memory, nope. Get memory arena buffer from the arena. size of symbol T. Right, and if symbol is not null, then we do symbol type equals type. But then I would have to. That's okay. That's kind of shit. No. No, that's okay. Let's not. Honestly, I might just make specific functions for like the different types I needed to add. I mean, keyword I only need to add with like some kind of meta program. So what I have to do in the end is basically in the build.bat. So, okay. Keywords I have to add manually, right, into my symbols table. Now, I could go ahead and in the beginning of the program just iterate like over some kind of keyword that I have and just add it in, you know, have an array of keywords essentially, of all those keywords types, and then just iterate through these enum or something, and then just push new symbols onto the hash map. But that's kind of shitty to write by hand. And every time you add a new keyword, you have to make sure to add it by hand again. And maybe what would be better to have some kind of meta program that generates the code for me to actually put that into the symbols table already. So basically, just add it to the right buckets for the hash map without having to call this like hash map insert value, where it then needs to check of whether it's in there and compute the hash. No, we just like compute the hash, and then we already know the slot, and then we just add it to the slot in the beginning of the program. But for that, I kind of need to write a little meta program and stuff like that. But that will be part for the next stream, I think. Let's just get labels working. Okay, so parsers. So we're opening a source file right here. And then what we want to do is... Wait, does open source file at the moment just exit the program if it fails? It does. Huh. Because the source file is empty. That's the only non-Windows error. Okay, whatever. Then we want to create a new tokenizer, right? Because that's what I added right here. So I have this new tokenizer thing. So let's create a tokenizer out of that source file. So we have tokenizer T, which is new tokenizer with the arena and the source file. Okay. So if this one fails, then we're just gonna write a last Windows error and exit for now. Failed to create tokenizer for files, so and so. Okay. And now I realized once I created the tokenizer, I did not populate the the current token and the next token. So I probably need to do that as well. So let's put this down here. Right, I'm just setting them to 0, which is technically not correct, right? So let's do read token, right? Actually, just this. And we do this for the current token and for the next token. And if this read token fails, it will just set the current token to end of file, which means, there's nothing to read for us. So essentially, we can adjust this code. The theme looks almost black and white for your eyes. All right. Can you read it, though? I don't know, I don't like too much syntax highlighting, but I really like kind of these darker purplish colors. That's why I went with this theme. What font is this? Firamono. Okay, so if I still want to print the tokens like before, what I can do now is basically just say this would be tokenizer current token. Right. But we probably want to set while tokenizer current token type is not end of file. Okay. Whoa. Okay. Whoa. Nope. Not the window I wanted. This is the one. Yeah, I should have fixed those before, shouldn't I? Token C. So what's the problem? Right, it's not tokenizer, it's result. Okay. File name, undeclared identifier. In program C37, file name. Indeed, it is source file. My bad. Program 37. Right, okay. This is a pointer. So let's use that. Okay. Right, and I did not advance, right? So it just, in an infinite loop, prints, wow, okay, I closed it. Great. Prints out the first token it finds. GB assembler alpha 3 build, right? So we need to advance right here. That is correct. So tokenizer advance tokenizer, right? Did I not? Advance. Okay, now run. Okay, cool. So at least the tokenizer works. Okay, parse source file, right? We have a source file that we want to parse. Actually, we want the tokenizer for that source file, right? Tokenizer. Assert that tokenizer is not null. And that should go in the parser.c. Okay, we can basically copy this code, I suppose. Right, for now. And just put that in here. Right, I have a memory arena that I use there, fine. Do I need to pass it in? I mean, if I want to print it out, I definitely need to, and I also need it for the symbols. So then the question is, maybe I should attach it to the tokenizer, so I don't have that many arguments. Why not? Right, I can just use the same arena as I did there. Result, arena. Right. Okay, so parse source file, tokenizer, and tokenizer arena. Same for here. Whoa. Right, and here. Built. Get token string. Oh, right, I had a little helper method. I completely forgot about that. There we go. Right. Probably can get rid of that soon, but this is just for the test. Okay, so now we have all this stuff in the parsing method. Okay, and this is essentially what we have to do while parsing, right? We loop over the current token that we have until we reach an end of file token. If we have reached the end of file, we just stop parsing. But instead of printing, what we want to do is, do something with those tokens. So let's say switch tokenizer current token type, right? Token type white space or token type new line or token type comment. We're just gonna ignore, right? So if we have a white space, new line, or a comment, just continue until we find something else, right? Or reach the end of the file. Now, this is something else that we're interested in. This is, okay, this is where I have to change the tokenizer a little bit as well. Because at the moment, I have two tokens, right? I have one for the identifier. The identifier could be foo, right? And then I have one for token type label, which is this thing right here. So ideally what I want is a label definition. So a label should be all of these things instead of having two separate tokens, right? And then if someone just writes a label like this, right, without a name, this just becomes an invalid label. Okay, so tokenizer. So read token. This is all fine, right? However, here we have label. And down here, identifier. Okay, so what I want to do is read the end of the token, which is fine, right? I'm wondering about some edge cases now. So let's say we have, so this is an identifier, right? This makes the identifier a label definition, right? What about having space in between, right? Should that still count? Probably not. This will just probably be an empty label, right? And then if we just have this, this is also just an empty label. So in this instance, this just becomes a symbol, which is like just floating around, and then, yeah. Right. So then we want to look ahead. So here I'm getting the code point and immediately swallowing it, which is fine. So this then will be like any character, right? So I'm reading that as kind of a symbol, which is fine. Then I just want to peek into the next code point, preferably without swallowing it for now, right? And then if this code point is a token CP label, then we have a label on our hands, right? So I can say token type label. And if that is the case, let's swallow that label as well, right? If it is anything else, we'll probably just have an identifier. Now this will include the label token at the end of it, but that's fine. We can just cut the string 1 character short. And otherwise, if we have a label right here, it's just going to be an empty label, which is fine as well. I think that's it. Yeah, okay, parser has issues. I know. Okay, so now we can actually distinguish between like just identifiers or labels. In this instance, we can actually be sure we have a label, right? Anything else is a syntax error for now, so we're just gonna throw an error right here. I don't need a break in the end, but I'm kind of used to this in case I want to move it. Okay. Okay, I do have this global error handling thing. Right here. And we can add a source file error. Which is not what we need. What we need is a token error, right? Hey, it's alright. Stop growling. It's a dog outside. Hey, come here. Come here. That's alright. Come here, little one. Come here. It's the protector of the house. Okay, so here we probably want the tokenizer pointer, and the tokenizer holds the file, so we can do something like this. Right, that will be the source file. And then we have... Where are you going? What are you up to? Do you want to go back to the bed? All right, there you go. And then we'll probably take the current token and we have the line of the current token. Hang on, what am I doing here? I want it this way. Right. I need to surround token pointer just in case. Yeah. So we have the line, the column, and the position. And then VA arcs. So the source file error is used, while reading the cone point, when we have like an error within the source file. And then this just takes the information out of the token. Because the source file can already, it's already advanced past that token. So that's why we store the token line and stuff right here. And then we can print that. So if we get anything else, let's just add an error token, and then we say tokenizer, right? And what do we want to write? For now, invalid token. I see. Maybe this is still useful. But then I should move this function into token.h. Right. So is code point token. I mean, it doesn't matter where it goes, right? If it's just for the error message, though, I'm inclined to just leave it like this. And maybe this one should really be living in token.h, because it is a token error that we're adding, right? So and then we can have u8 get token c string token type. And sure. Oh, it's an S8. Sorry. I need a proper token error message, because, like, depending on the type, you probably want some other information, right? So with the identifier, you don't want to just say identifier. You actually want the identifier value and print that out to the user. So you can then say invalid identifier is this. But let's just use this for now and just see, that it works. So invalid token, right, this one. And this would be get token c string tokenizer current token type. Okay. So let's remove all of this. And then we just have advance regardless of whether it is an error or not, right? Because an error is not terminating anything. We just want to continue parsing the whole file and just print out every single error that exists within that file. So the user can potentially go ahead and just fix all of them at once instead of, you know, compiling and then like, oh no, I have an error, fix that error, compile again. Oh no, there's another error, right? Why not just do them all at once? It's kind of nicer. Okay, so if I build and run this, what? Line 17, what's the problem? Oh, file dot file name. What? Oh, it is a pointer indeed. My bad. Okay. There we go. So this is how error messages would look like, right? So you have the file name at the beginning right here, so you know which file the error is coming from. Then you have the line that error happened, the column that error happened, and then the byte position. I'll probably make a flag to enable or disable the byte position if necessary, but I kind of like having it. And then you just have error and then invalid token number. Right. So the error messages are not great at the moment, but as you can see, anything that is not a label is essentially an error. So yeah. Cool. Love the 0.00 seconds right here. The overall runtime. That's nice. Yeah, I don't think I need to go more granular than 2 points though, so it's fine. It's fine. It will usually take longer than this, right? You will have bigger files. Anyways, okay, so labels. So if we have a label, the first thing is to check if it exists in symbols table, right? And then if yes, error. If no, add. So let's get to it. How do we do this? We need a symbols table, first of all, right? I mean, we already have that. That is our hash map. Sorry, there we go. So there are symbols. Now, since we're kind of using the tokenizer as a context, we can just attach the symbols table to the tokenizer itself. So whenever we pass the tokenizer, we have the symbols table as well. That's probably the best way of doing it. So, well, I wouldn't go as far as saying it's the best way, but it is a way of doing it. So let's just put symbols in here. And then on new tokenizer, we want symbols as well. And then symbols. And we'll probably want to say symbols is not null. There we go. And then result symbols. All right. So now we have access to the symbols table. So I could make it two different ways now. I could either try and get the value, right? And if it returns null, add it. But that will be redundant because insert also already checks whether it's there or not. And if it is there, whatever it returns, will be different. Okay, so let me refresh my mind on how I did this. Make it nicer somehow. Right, okay, I forgot about that to do. So if it already exists, we're just going to return what's in there, and it is the hash map item. And the hash map item essentially just points to a value, right? If this value is the same address as what we pass in for that value, then we have inserted our item. If, however, that address is not the same as this one, then the item already existed. Now, another way to do this, because this would mean I would have to create what I want to put into the hash map first, but that kind of would be a waste of time as well, because, if it's already in there and I'm creating it before I try to put it in there, it's kind of unnecessary. So what I can do is I can just pass in null in here, get this thing back, and then check the value. And if the value is null, then, hey, this is a new entry and we can actually populate it. But if it is not null, then, something was already in there. Right, so let's do that. And I wonder if I should put this in a new function that does all that for me. And just call it like add label definition, if it exists. And if not, we just record an error in the global error handler and continue parsing anyways. So we do also need to worry about like return values or anything like that. Which makes the code a bit nicer to read, I think. Or let's say easier to reason about, I suppose. I don't know. Yeah, let's do that. So, void add label definition. So, okay, we need the memory arena. And we need the hash map. just call it symbols. And then we need to add the... Oh, we can just pass in the token, to be honest. But no, I need to build... You know what, before I put this in separate method, let's just try and write it out as is in the parser, and then I can think about how to like split this up and what I actually need and don't need. Okay, so symbols table. So tokenizer, hang on, what was the, yeah, this one. So hash map insert value, this will be tokenizer symbols. Then we need to create a key, right? Yep. Okay, let's do that. Let's call it the identifier, right? The identifier comes from the current token. How about we do this? Token. Right. I'm just too lazy to type current token all the time. Tokenize a current token. It's a bit of a mouthful. Okay. So from the token, we have a position in the source file and the length of it, right? So this will give us the string of the identifier. And now I just need to make a string type out of it so I can use it in my hash map thing, essentially. So what that means is we need a string, right? A new string. Did I just name this string or new string? I never know. Just string. Okay, fine. So string, and essentially that means we have tokenizer file base So this is an ideal candidate to make like, you know, a macro out of this, or like a little function that returns you, that transforms a token into a string. have not decided yet. So then we have token, position, right? And let's get the address of this. I don't like pointer arithmetic, so I kind of like these indexing things, and then just get the address of it. And then we have the length, and that will just be token length, right? Okay. To do report an error if token length is bigger than S32 max, because that is the maximum string size we can actually do. Okay, so that is our identifier string. What did I change here? Okay, whatever. So that will be the key, the identifier. And then the value will just be 0, right? And then we have an hashmap item. So now, if item data, I think I called it. No, value. If item value is 0, then this is a new definition, right? Otherwise, this already exists. Okay. So let's do the new definition part first. If this is a completely new definition, I need to create a new symbol, right? Basically a new label definition like here. So let's do label definition. New label definition in the arena. And what we want is okay. I'm already spiraling out again. I need to come up with a nicer way of doing this, but okay, let's just let's create a new symbol first, right? Because that's what we need. We have the arena, and the symbol type will be symbol type label. Okay. Right. I don't know what to do when the allocation fails. probably just a hard exit, but I'll think about it later. Okay, we have a symbol type, and then what we need to do is add the label address onto it, but for that we need a label first, right? So let's create a label. Basically, get memory arena buffer. Tokenizer arena. Right. Hang on, I had a macro for this, didn't I? Every time. Get memory arena type. Okay. Get memory arena type. Type will be label definition T. Okay, if label is null, okay, label address, we do not have that at the moment. To do, fetch the current address of the output file, right? So we can deal with the address in two different ways. Like either we just leave them all as 0, essentially, and then we can't really do that, can we? No, there's only one way. So as we build the output file, we kind of know where we are in the position, right? Because every time we pass something, we immediately write the bytes into the output file. And depending on where we are in this position, the label definition then has the same address of the current position as we are in the output file at the moment. So I need to kind of fetch it. I assume we just attach the output file to the tokenizer and then have like some methods to help me get this. But okay, then we have the label file name, which is tokenizer file name, right? We have the label line, which is actually, yeah, token line, label column, token column, and label position, token position. Okay, then we can say symbol label is label, right? And then we can say item value is symbol. There we go. Obviously, this would be way nicer to have in a function, and I'll think about this shortly on how to actually move that around and stuff like that, but it wasn't quite clear to me what I need to refer to, like, maybe I just pass in the tokenizer as well and just, have a little function that deals with that stuff down here instead of having it in the symbols stuff. I'm not sure I like the separation the way I did it, to be honest, but I'll think about it later. famous last words, and then it always stays like this. You know, I actually do not want to call out into this one. Let's do it. Because I don't know if I like that function like this anyway, so let's do it this way. Right, and then let's get rid of this one. For now. Right. So this error reporting, whether a token is longer than what we actually allow, I wonder if that should be in the token processing itself, and it just basically turns out to be a null token then in that sense, or I don't know. We'll see. Okay, but then if it already exists, right, we want to print out an error of where it exists and what it actually is, right? For example, a label might have the same name as a keyword, right? So then we kind of need to distinguish between those two different errors, because we then need to say you cannot name labels the same as keywords, right? And this kind of stuff. So essentially what we want is get the symbol, right, which is symbol T, out of item value, right? Okay, so now we have the symbol. We can then figure out what kind of type our symbol is, right? We have the symbol types right here. At the moment, it's just, whoops. So it's either a keyword or a label, right? So if it is a keyword, I don't have a macro for this yet, so I'm just going to call add error directly, which will be a bit of a mouthful, but, you know, let's do it the straightforward way and then see what we can do to make it nicer. So file name, that would be tokenizer file name, right? Then we have token line. Wait, is this just a token error? It's just a token error. Never mind. Okay. Labels cannot have the same name as keywords. right? And then we have the actual keyword that we already used, which in this case would be identifier. Oh, hang on. So I need, yeah, I already have it up here. Okay, cool. So identifier length and base. There we go. We won't see this error at the moment because I do not have any keywords defined, but maybe we can just add one real quick just to make sure that it works as intended, right? So, and then here we want a bit more of a specific error, right? So it is still a token error, right? Tokenizer. But we have a bit more information here. So label %s is already defined in, and then we have the file name, and then we can have the sorry, no, where was it? Where did I put this? Ah, my lord. Nope. Yes, here. So we want the line, column, and byte offset of where it is defined, right? So we have label so-and-so is already defined in file this, right? And then the exact location of where it is defined. So that would be... Right, identifier length, identifier base, right? And then we need the actual label definition out of that symbol. Symbol label, right? And then that would be label file name. No, sorry. File name length and label file name base. And then label line, label column, label position. Okay. And I'm sure this pattern will repeat itself later on with like other labels and when you call out into labels and all this kind of stuff. So it would be really good to have this in separate like functions and like some nice macros to do this. But like I said, I'll get to that later. Let's just see what happens. So we have built, right? And now we have to fix some errors, which not surprising, right? This is token pointer, line 16. What's wrong here? Conversion from U64 to U32. Right, because this is... Yeah, I really need to make something nicer for this overall, but okay, let's just cast and hope for the best. Okay, what's here? Cannot convert from token to token pointer. But aren't you... Oh, right, okay, fine. Probably need to do the same thing here then. New tokenizer, too few arguments for the call. Okay. That would be correct, because we also need to pass in these symbols. Cool. Run! Okay, so there's a bunch of errors with like all the tokens still happening. Right, let me actually zoom in. Okay, let's stop error printing for a while and just check labels. Hang on. I really need another coffee, man. Okay, I'm just like... Okay, let me comment this out, right? And then run. So, no errors, because this is actually a fully functioning program that we're trying to compile here, right? But let's say we have... well, we have entry point here, but what if we define it again? Run. Oh, oops. It appears I'm printing the whole file. This is because this is not null terminated, so at some point I'm looking for null termination, and where though? Oh dear. Where do I do this? Okay, here. So this identifier is not null terminated, right? Which is fine, because in my code, I actually also check the length and usually go by the length. Right? I never just go for null terminated strings, usually. The only time I want to have null terminated strings is if I call into an API that has nothing, nothing that prevents that. So what is going on? Label is already defined in, what's the actual error message, right? Error, label entry point. Okay, so it is the first identifier here. But why? I do specify a length. Is the length not correct? Maybe the length is not correct. Let's figure it out. Parse source file. Right, let's go here. Okay, so what? Excusez-moi? What just happened? What? Oh, I hate this so much. Right. It's not running in the right folder. Hang on. Okay. I can zoom in a little bit here as well if that helps. Okay, so we have token, and that one, it's a token type label. We have a position, and the length is 11. That sounds about right, doesn't it? Okay, so identifier, right? So let's jump one further. I mean, yes, it has all of this in there because it's not null terminated, right? But we specifically set the length to 11. I mean, this is just a pointer into the file, essentially, right now. Which is fine, right? Okay, we create a new symbol. Ah. No, that doesn't explain it. Okay. What? What am I doing wrong? It must be like... Is that not the way to specify the length? I thought it was. Am I going crazy? I am going crazy. Okay, apparently I need the dot. Well, that is good to know. So let's please find all of these and change that. Oh, sorry, completely wrong file. Okay. GB assembler in alpha 03. Well, that is good to know, isn't it? Well, that's the assembly file. I don't need that. Okay. What? No. Wait, can you not? Did you change it? No, you can't change stuff in there. Ah, man. Okay. Right. Let's see. No, that's not what I wanted. God damn it. Okay, I also did that in here. Learn your library. That is a good start. Okay, cool. So now the error... Let me clear all of that, right, and run again. So now the error actually works. It now says in program gbasm, right? So if we look in this file, it says on line 23, right? So let's go line 23, column 1. So right here, all right? Error label entry point, right? This one is already defined in data program gbasm, right? On line 13, there we go, column 1. And indeed it is. Perfect. So the only thing that kind of is bothering me is that the label has this thing right here, right? And actually we also do want to remove that. So in, where is it? In parsing, when we do the identifier, we already know that this token always has the colon at the end of it because it is a label, right? We already know it's a type label. And we know there's a colon in there, so what we could essentially do is basically say just length -1, right? That works. But why not do that in the token itself, to be honest? That is probably better. Because I calculate the length all the way at the end. I mean, we could go a bit cheeky and be like, hey, you know, this length thing that you have right here, right? How about you subtract that as well? And then if we have a label, we can say length modifier is 1. Right? So there we go. Now the token has actually the right length. Yay! Okay, so that is cool. Now let's try and provoke the other error message. So the keyword one, right? So for that, we're just going to add a quick keyword. Quick. Let's do that here. And let's say to do remove me. Right. Whoop. I thought I copied code. Apparently I did not. I want to copy this. Okay, get memory arena type symbol, right? We do not care about error checking at the moment here. Whatever, right? If we have a symbol, let's make it a symbol type keyword, right? And then the symbol value, I think. No, it's just keyword, right? Because we have a keyword type, and the keyword will just be one of those enum values. So let's say, nope, keyword. Let's make swap, right? And then we can add that symbol just by doing this. I mean, I'm just going to ignore the return value because we know it doesn't exist, right? So we can just say symbols. And the identifier, well, that will be a string literal. And what we want is swap. And the data we attach to it will just be symbol. There we go. And now if we build and assignment within conditional expression 17. What? Oh yeah. Oh no. 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 We just run. Okay, cool. And now let's say we have a label called swap. Line 12. Yep. Column 1. Fantastic error. Labels cannot have the same name as keywords. Swap. Cool. Now, what we have not thought about is this instance. And foo with like a bunch of white space, right? So we need to take care of these two things. At the moment, this will probably blow up, right? Nice. Label colon is already defined. Right. That is because, right, two things to fix here. So in the tokenizer, if we actually just encounter this, the length will be 1, right? Because it's the colon. So really what we want is the length modifier to 1, right? And then, yeah, this will blow up. Okay. I don't know what it did, but it did something, but not the right thing. Okay. Which is a bit concerning, but... so then in parser, here, when we have the identifier, we probably also want to check that this token is not null, right? So if token length is null, then we want to add a token error with tokenizer. And what we're going to say here is empty label definition is not allowed. Right. Something like this. Whoops. Build. Run. Okay. Line 12 cannot be the same as keyword, right? Line 14. Empty label definition not allowed. Cool. And then we have another one on line 15 which says empty label definition not allowed, because strictly speaking this is empty. Now if we enable the normal error reporting, this would just be, you know, a symbol name, and then it would print out an error saying, hey, there's a symbol name here which is not allowed either, right? So okay, I like this. I like this error reporting style a lot, honestly. That is cool. Quite happy with this. But there's another thing I have not thought about. Okay, so remember I have a dictionary, right? So this is to find similar labels. So if you had a typo, let's say, oh dear, I'm alt-tabbing all in the wrong directions, right? So let's say swap, for example, but you actually type in later on when you want to use that label, right? Let's say you have jump to swap, but for some reason you write swox, right? Because maybe you had a few drinks, you don't know what you're doing, right? So instead of just saying swox is an invalid label, right? We don't know what it is. I actually also want to say, did you mean to say swap, right? Because we know swap exists. And the way I'm doing this is I have a separate dictionary where I just fill in all the symbol names that are possible, right? Put them all in there. And then basically once we encounter an error like this, where it is a symbol error, like a symbol that we cannot find, we're just going to do a linear search over at the moment, it's a linear search over the whole dictionary, which is in sequence in memory anyway, so it's fine because it's using its own memory arena. I mean, not at the moment, but it will in the future, right? And then based on a few things of like string length and stuff, it either bails out early or it actually does a comparison and then figures out, gets a list of items that are similar. And then it gives you a few options, right? I have not decided of how many options yet and things like that. That code is not done yet. It is in the to-dos, like all of this stuff right here. But once we have a new label definition, I also need to add it to the dictionary, essentially. So dictionary add string right here, right? And what this is doing, it basically takes the string and wait, hang on. Yes, it and does a copy of that string, right? So there's a mem copy involved. And then for the comparison of the strings, I use the Levenstein distance to then calculate like the difference between those. Okay, so I need to add that to the dictionary, right? So, and then it returns the copy of that thing, which will then become the new string that we actually should refer to. Oh, Well, that is a problem. I have not thought about that. So at the moment, hashmap insert value will have this string as the main string, right? Which is pointing to the file memory. So it's not actually a copy, right? But I think we do actually need to have a copy here, because if I insert it like so, it needs to be the copy. Because, yeah, if the file closes, that string will point to invalid memory, right? And the reason why I'm saying if this file closes, at the moment there's just one assembly file, right? But that assembly file could have includes, which are other files. So, and those include files only get parsed and then immediately closed, right? I don't want to hold on to them in memory for like the entire duration of the parsing of the main file. If it's just in the main file, it's not a problem, because the main file just stays open as long, as the program runs, essentially, right? And the file just lives in memory anyways, because it's not that huge. So maybe I'll just copy anyways. So there's a few ways of solving this, right? Either copy the string no matter what, right? Second, after establishing that the item is new to the hash map, modify the key to a copy. That kind of is awkward. I think I just copy no matter what. I have a copy string method down here, but that is not quite what I want. Because that means I would have to create a string first and then call this. I mean, technically not that bad, but maybe I could have an initializer that's like string copy, right? And that will initialize a new string with a copy already, so I don't have to go over this step. This is more like if you already have something like this available and copied around, passed around in your program, and then you want to create a second copy of it, then you can use this. So yeah, let's do that. Okay, so we have assert base is not 0 and s32 max bigger equal length, right? I mean, I can basically just take this. Right, it also needs a memory arena, of course. Right. Memory arena. Okay. Result base is this, right? That will be length plus 1 for the null termination, and then right. if result base is not null, then we actually will be able to allocate. So then we do this, right? And mem copy into result base from base and length, and then no, value length was no length. Okay. So this would become string copy with tokenizer arena, right? Oh. No, okay, this already copies. Okay. Yeah. This is fine. This is fine. I was worried for a second that error would hold on to the string as well, and then if one of the include files gets closed, then it would point to like some shoddy memory, and then no. But it's all fine, all fine. Okay, so if this is indeed a new definition, then we also want to add it to the dictionary, right? So dictionary, we have this little thing right here where we can say, right, but the tokenizer should probably also hold on to the dictionary. I kind of don't like how it's blowing up. To be fair, I could probably just make the symbol table, the dictionary, just globals, and the arena as well, actually. Because, I mean, they do live throughout the entire program runtime. And then I can just refer to them globally instead of, like, having this bulky type where I add everything in there and, like, nothing wrong with a global. Especially not in a non-multi-threaded program, right? Yeah, I'll probably do that. Okay. I mean, really, if this fails, if like any of the global stuff fails, really what you want is to actually terminate anyways. So nope, not error. Is it in console? Yeah. Right, last Windows error and exit. Wait, how does this construct the message again? Ah, okay. Okay. Is this how I used it mostly? I use the colon, okay. Fine. So this will also exit the process and print like a Windows error, which is what most likely happens if Get Memory Arena actually ever fails. Then it's usually just because of a Windows error, because virtual alloc has failed in some instance. And then we just exit the process. We try to print an error message, which probably won't work, but you know, we try. And if it doesn't work, it probably will just crash, and then it's fine. Crash and burn. It's also a way to exit a program, right? Okay, so we have a global dictionary. Right. Ah, you with your highlights. Ah, man. Okay. And edit distance is not being used anyway right now anyways. Okay. Hang on, but now because I have this, I probably do not need to make a copy right here, right? So that is actually nonsense. This is just holding on to the value, which means this can be a void. Or a boolean. Let's make this a boolean. Okay, so this is then becoming get get memory arena type, I think. Yeah, one day I will learn all these macros. The arena, and the type will be dictionary entry T. And that will be our entry. Now, if entry is not null, then we do what we need to do here, except we no longer need to copy stuff around. What we're doing is entry value equals value, right? Actually, don't I also have... failure is better. Just makes more sense to call it failure and success instead of true and false. Same values, just different ways of writing it. Okay. So now in here, we're adding the identifier, and if it is a failure, then we'll try and figure out what to do. I have to think about this a bit more, like what I want to do in those instances. We'll see. Okay, but then I also need to... So this becomes dictionary add string, right? And then this is init global dictionary. And I probably want to call this let's just call it here for now. It needs its own arena. Okay. What did I do wrong here? Oh, right. I did not update this, did I? Right. Okay, cool. Wait. Did I just screw up? Where did it go? Why is it no longer showing the swap error? Huh? What? What just happened? Okay, empty label definition not allowed, right? This still works. Okay. Where are all the breakpoints? Oh, I cannot. Right, okay, so this should be in there, right? So we can check that. And then, what? Oh, right, you need to jump in to open it? Okay, fine. So we want to go in here with string copy, and then we also want to check here the error. Right? Okay. So, symbol, keyword, yes. It's not a label. Okay. Symbols. Base. This would be an array. Come on, man. An array of symbols capacity. Okay. Let's look for a bucket, entry, key, swap. So can I cast this? No. Well, anyway, something is in there. So then identifier is swap. Why is it 5 characters? because I'm counting the null character, which I shouldn't. Right. Okay, my bad. So this length plus 1 is still right, but length right here is just gonna be length, right? And then yeah. There we go. So what happened is it was actually counting the 0 termination character for the hash calculation as well, and then probably didn't find it because the initial swap didn't have the 0 termination, right? So the hash was slightly different, and that's why I thought swap wasn't in there. That was me screwing up the copy methods. Did I actually... Well, I did it correct down here, and then I copy-pasted it and did it wrong. That's also a special talent to have, isn't it? All right. I think this is where I'm going to leave it for today. I will put up the source code of all of this onto the Ko-fi page, this time for real. Right? Last time it just didn't feel right because it didn't have a natural ending point, but now we actually have, you know, we actually have something that can run over a file, and the only errors it I mean, it doesn't do anything useful yet, right? It just passes over the files and checks for the tokens. But one useful thing it does is if you have labels in there and you already have like multiple label definitions, it will at least throw you an error. So I think that's good enough for Alpha 3. And then so this is for labels, and the way the parsing works right now, I mean, I really want to put this in a separate function, right? That is okay. To do make nice functions for this stuff, right? But the way it essentially works, like you could have multiple labels after each other, and it would just work. So it actually parses all those labels, and until later on it encounters something else, and then we start parsing the line in itself, right? So really what we want to check for is a keyword, and I am inclined to maybe add a separate token for a keyword instead of just having identifier, right? So keyword. But then, no, I don't know. Maybe it is a good idea to do that, because then I don't have to have this check everywhere, right? Every time I have an identifier to check if the identifier is a keyword and then report an error. Because if we can already in the tokenizer determine that it is a keyword, I can just treat it as that, and every time I encounter a keyword, I say like, oh, I didn't expect a keyword in here, right? So what the hell are you doing? but then the error reporting would be... Oh, no. I would still need this for the label case anyways, because now we combined labels. I'll think about it offline. I mean, I have until Monday anyways, right? So maybe it would be a good idea to already resolve token names here. Especially once the symbol table becomes a global as well. It should be fairly easy to do. But then... But then I would be checking twice. I would be checking the symbols table twice, right? I cannot have this streamlined like so. So I'm getting an identifier, and in order to figure out whether it is a keyword or not, I would have to call hashmap get value and then see if it is actually a valid value. And if it is a valid value, I have to figure out if it is a keyword, and only then if it is a keyword, I can set the token type to be a keyword. But then that means I already have to do the check for every single identifier, only to then realize if it is not a keyword to then do this whole hash map insert again. So I would be doing it twice. I mean, it's probably not an issue, but it just doesn't sit right with me, you know. I'm already annoyed with the string copy here, but it is what it is. I'll figure it out. Okay, so implement symbol types. Well, we have symbol definitions. So who's are, right? Keywords. Yeah, I wouldn't want to claim we have implemented keywords because they still need to be put into the hash map, right? So think about token buffers. We kind of thought about it, right? We have the current token and the next token because we probably only need to look ahead one token at a time. Possibly, perhaps, I don't know. Maybe I need more, but then I can just change the way of doing things right now. Implement basic command line options for input and output files, right? This is something that needs to be done next time. Okay, what do I want to do? I want symbols tables. Symbols table should be a global like the dictionary, right? Because that is used everywhere. Maybe make global arena also a true global, right? Actually, no, I do not want to make the arena a global because just having the arena and calling like a global arena somewhere in the code just makes it not really obvious whether it's allocating or not. Having to pass an arena into the function kind of helps me to realize, oh, whatever I'm doing here is actually allocating some memory, right? Allocating. Okay, and then what we should do is write a sort of meta program. I don't like to call this meta program, but no. Fine, I'll just leave it like that. That is so write a sort of meta program that is adding all the keywords into the symbols table. So basically code gen, right? So you have to imagine it like this. I just have in my build.bat, as opposed to building the main program right away, I'm going to build like a code gen program first, right? And that one will have, information about all the keywords and then adding it into the symbols table and then generate code out of it. So I can just statically add during compile time everything into the hash map buckets. So I don't have to do this during the runtime of the program. So it will just create a C file out of this, and then the next build step will, build the main program with the generated C file included. But that is for Monday. Did my Ko-fi page disappear? Because the stream crashed. Okay. So again, I will be putting up the source code to everything on my Ko-fi page for monthly subscribers if anyone is interested. So you get access to all of this, and you can play around with it, share it, do whatever you want with it, because it's just licensed under a modified BSD license right here. And the next stream will be on Monday. So I'm always streaming Monday and Wednesday. And on Friday, I will be releasing a new YouTube video. As a small sneak peek, the new YouTube video will be about reading header data from GameBoy ROM files, essentially. So, and that's it from my side. I really need another coffee and some food, and I probably need to take the dog out as well. So, thanks for watching. Are there any questions? If there's any questions, now is the chance to write them in the chat. If you have some more questions, I'll give you a minute or two. I ran out of water as well. Gee. It's really time I stop. It's not too bad this time. I overshoot for only like 20 minutes, 25 minutes. Right, I also need to update the text files right here and the README. No, we are in April already. Jeez, time flies, dude. Well, not sure. I will be pushing it up today, maybe tomorrow, but nah, I should do it today. I should do it today. Okay. By the way, if anyone is interested, because I'm not using Git, the way I compare versions is also quite funny. I have WinMerge right here, and can just go open, right? And then I can say, well, I want to compare the folder of alpha 3 versus alpha 2, right? Click compare. And then I have all the changes that I did. Like, so how did we change the program file here? And I don't know, Dani Arena. Okay. Changed some casing, that's it. Token. Well, there's a few changes in here. Yeah. Right, and these are new files. Anyways, I guess there's no questions, so I'm gonna end it. Thanks for watching, and I'll see you, well, Monday, I hope. All right, bye.